So problem 7.14 says the switch in the circuit has been closed for a long time before opening at time equals 0. Find V naught for t greater or equal than 0. So before 0, we know the switch has been closed, right? So this current, this 4 amps, this current is gonna follow the path of least resistance, and we know before the 0, this inductor is gonna already be a wire by then. So let me say the current here, IL, I'm gonna call that 4 amps, right? So IL for t less than 0 is 4 amps, right? Okay, so then you go ahead, and once we see the circuit, the switch opens, we're gonna see that this side here is gonna disappear. So we're left with this. Right. All right. So I'm gonna make a list of things we need to know here. So well, with this circuit here, we're not really able to formulate an equation for the current, right? The dependent source kind of tricks us there. And we're not able to find an equation that looks like this. Right, and but what we do know is that tau, to find the tau of inductors, it would be the equivalent inductance over equivalent resistance. So since we only have one inductor, our equivalent inductance would be 5 millihenry, but we need to find an R equivalent. So what we can do here is we can find an R equivalent by using our Thevenin or Norton equivalent technique, right? So I'm gonna go ahead and plug in a battery. I'm gonna say it's 1 volt. And I'm gonna actually change this. I'm gonna call it VT. The current going across is gonna be IT, right? So do the circuit analysis, 1 volt. Say this is ground. So we know that IT equals 4 VT, right? And we know that our VT equals 1, so IT is 4, and right. So we know Ohm's law, V equals IR. We know that R equals V over I. So 1 over 4 is going to be our R equivalent, right? So with our R equivalent here, we're able to calculate tau. So we got 5 millihenry over 0.25. And use our calculator. So 3 over 0.25 is going to be equal to 0.02. Okay. All right. So now we can replace that dependent current source with a resistor, our equivalent. Have an inductor here. It's going to be 1 over 4, 5 millihenry. We know our tau. Okay, and yeah. Say we have a current delivering. So yeah. So I guess our next step for, well, know that the, yeah, okay. I guess now we can go ahead and do our IT. You know our tau now? Yeah. So we know that I times 0 is going to be 4 amps, right? And at time infinity, it's going to be 0. So we're going to have a 0, 4, 0. E times t over 0.02. Which is negative 50t for current of the inductor. And now it wants us to find V naught. So for our V naught, we know the inductance 5 millihenry times derivative of this current, this function of current. It's going to be negative 200 e to negative 50t. Yeah. T, and that's 5e to 3 times. So it's going to be negative 1. E to negative 50t for t greater than 0. And yeah, this is the solution to our problem.